It's finally time for calculus. Math 1160, now called Survey of Calculus, is one of my favorite courses, and I've just been chomping at the bit trying to get ready and anxious to get going on how we're going to do Math 1160. Let me start with this. The course is now called Survey of Calculus, but it used to be Applied Calculus. And in my mind, it's still Applied Calculus. It's designed for people who are going to take one semester of calculus and apply it to something else, to something in your major or in your area of study. And I have found over the years that while I really enjoy abstract calculus in my non-professor life, which is pretty extensive, um, I find the way that I think about calculus and applications has really made a big improvement in my ability to understand the world. And so that's what we're aiming at in this course. So we're going to use calculus to understand questions about the world, to tell stories about the world. And so that's the plan. There's let me just do a little bit of logistics. This course does not have any specific meeting times. You're going to watch videos like this, and you can watch them over and over again. I've left last semester's videos up and available, so you might even be able to get a slightly different perspective. One of the amazing things about calculus is that even though I've been doing it for a century, if you round to the nearest century, I'm still learning new stuff about it. It's an amazingly deep subject. And so this semester will be different from last semester, and next semester will be different from this semester. It's really just an amazingly versatile subject. So that's what we're going to do. The basic idea of applications is to make mathematical models of things that we observe in the world. And in calculus, we mostly do this with functions. So the way I like to put it is sailors work with water, pilots work with air, weavers work with yarn, and calculusers, whatever you call us, work with functions. And so what I want to do for now is to give you some reminders about functions and give you a little twist on the perspective that is useful for using functions to do calculus. And this is in my book, which is exerted on the Moodle site. Everything's on the Moodle site except for WebAssign. And and this is how I think about calculus. It's been very successful. So we're going to talk about functions, and well, let's just get going. So as we talk, I'm going to be making notes. At the end, I will scan this and put it up on Moodle so you can refer to it at your leisure and over again. So there are things that you studied about functions in pre-calculus that are correct, but maybe not as useful as you might need. So let's talk about some useful things about functions. First of all, I classify functions into two categories. You won't hear this anyplace else. I made this up. I made this up based on experience and what I've done with functions and what I've seen other people do with functions over the years. So there are two kinds of functions, and this is going to sound like grammar. It is grammar, and because calculus is a language. It's a language we use to tell stories about the world. So the two kinds of functions are active and passive, and these both come up in calculus quite often, and we use them. Passive has to do with data. So if we make a table of values of some function, which I'm doing, this is incredibly boring video, I know, while I'm just writing out the table of values. So I've got some x values, and then I'll put in some y values, and that is what we know about this function. And so this is typically what happens with data. Now, this is not data right here. This is something I made up. You know, it is a song, 8675309. And so this is a passive function. We can't do anything with it. We can't have it work on anything. And so that's what makes it passive. It just sits there. It's what's recorded on a barograph or a seismograph or some kind of laboratory data. An active function usually means, not always, but generally means that we have a formula. And formulas are tricky. So here's a formula for an active function. I want to talk about how to read this formula, but for the moment, let's just say, hey, look, you know, I can put in any value of x that I feel like here. Now, some values of x are going to make this function undefined because you're going to be trying to take a square root of a negative number. So that's the domain. But there are a lot of values of x that you can put in, and you can make sense of what happens here. You may not be able to calculate it exactly, but that's what happens in the real world. We use approximations, and so we have an approximation possibly, but we can do it to any x. It acts on any x that is in its domain. So that's the situation. A model is an active function that duplicates or approximates a passive function. So you got data, that's the passive function, and you come up with a model, that's the active function, and that's what we're aiming to do. Calculus does that by keeping track of changes, and so that's the real calculus perspective, is to keep track of changes. So this is an active function approximating, that's too long to write out, a passive function. Passive function is data. So here's the definition of model here, and just a reminder that passive functions are data, and active functions are models. Okay, so let's talk a little bit about function notation. When we talk about and say y is equal to f of x, we've got a couple of things that are going on here that we need to be reminded of. F is the name of the function, and y is the output, and x is the input, and that's kind of the standard thing. So you have an input, 0.1, say, in this thing over here, and you plug it in and you do whatever the function does. A function is what it does, and out comes some other number, and so that's it. That's the whole process. It's a little bit hard to picture what the function does because we get so focused on x, and so what we need to do is to we can use this notation, but when we get a formula is what the function does to x. So if I take the function that I had up above, I'm going to do one of my favorite things, is I do the parentheses first. So I'm going to have some input, and what I'm going to do is square the input, subtract it from 1, then take the square root. And when I talk about functions, I try to talk about functions in the order in which they work. And so I'm going to use a little color coding here. F of 0, I'm doing that in red, is, well, I just put the input there. And f of a half, I'll make that in green, is, well, I just put the input there. What a lot of people do when they see a formula is they'll say f of a half is square root of 1 minus a half squared, and then they'll try to work on it straight away. Do the parentheses first. Set it up this way. A lot of this is just cut and paste. There's a half here, so you put a half here. If there were 2 instances of x in the formula, you would put a half in 2 different places. That's not all that unusual. And so we do the parentheses first. Do the parentheses first. Organize things before you start to simplify. In many cases, it's not necessary to simplify. People have been telling you your whole mathematical lives to simplify, simplify, simplify. But let's really simplify by not doing too much algebra. Don't do algebra unless we have to. And especially if you're doing something with a calculator or a computer, let the computer or the calculator do the computing and the calculation as much as you can. You have to set it up. Okay. So let me go through an example of an active function given by a formula. And I want to talk about how to read this function. So I'm going to not say anything. I'm going to shut up while I write it. Because when we read it. Okay. So there's the function. And everyone's going to look at this and say, oh, it's 4x over 1, or x squared plus 1. That is not correct. It is correct, but it's not useful. There's a more useful way to say it. And when I look at this, I say, what is the most important thing about this function? And the answer is that it's a fraction. And so before you starting at the upper left and working your way down to the lower right, like you're reading the newspaper, the most important thing is it's a fraction. This is the way we do things in mathematics. We take them apart to see what's really gone on. And so if you're going to calculate this, if you're going to put in like 3 for x, what you're going to do is you're going to calculate the top and you're going to calculate the bottom, and then you're going to divide. You're not going to divide. You're just going to write that you're going to divide. You're not going to divide unless you really need to divide. So let's see what happens here. So when I look at that formula, the first thing I say is it's a fraction. It is. It's a fraction. That's the most important thing. Now, being a fraction means there are going to be 2 components to it. So then the first thing I say is, oh, which is more important, the top or the bottom? Now, in this case, it's not, but see this scar? I got this in 8th grade by not paying attention to what was on the bottom. And so the bottom of this fraction is a sum, and it's 1 plus the input squared. I'm going to write square of input. This seems awkward at first, but this is how you understand functions and formulas and do something useful with them. So where's the lining? It's a fraction. The bottom is 1 plus the input squared, or the square of the input. That's what this formula here is trying to tell you, and so that's how the function works. The other thing that we would know about this is what's the top, and the top is 4 times the input. Now, when you do this to x, you get the formula that I wrote down. If you do this to 7, you correctly calculate the value of the function at 7. If you do this to -1, you correctly calculate the value of the function at -1. You say, it's a fraction. Let's just do this as an example. F of -1 is, and now when it comes out printed out, you're not going to see this, so you have to pay attention to the sequence here. Number 1, it's a fraction. There it is. It's a fraction. And for the sake of time, I'm just going to say the top is 4 times the input. I'm not going to write the input. I'm just going to say 4 times the input. And the bottom is the input squared plus 1. And the input here is -1. So I'm now going to fill in these parentheses. -1 and -1. That's why I'm saying sometimes the input appears more than once. And so you fill in the parentheses, -1, -1. And that's it. That's the value of the function. Now, you may need to get a numerical value out of this, as far as what are you going to tell the purchasing department about how many spools of wire to buy, or something applied like that. I hope not for this one, because that would be a negative number. But the stopping and thinking and organizing what's going on with the function makes your understanding of the function and your ability to work with the function much stronger. So here it is, the original formula, and it's a fraction. Top is 4x, bottom is x squared plus 1. Don't have to worry about the bottom being 0. And if we do this to -1, the top is 4 times the input over the bottom, which is the input squared plus 1. And so the chance of actually evaluating this function correctly is much higher. This is not an extra step. This is a step that too many people skip. So let's just finish this one off. And so that's an easy enough situation. It's still a fraction. The top is 4 times minus 1. That's minus 4. We're breaking this down into a lot of very simple steps. And the bottom is minus 1 squared. That's 1 plus 1. So the top is minus 4 and the bottom is 2. And the net result is that the value of the function at that point is minus 2. It's an active function. I could put in anything I want. I put in minus 1. I got minus 2. I could put in pi. I would get something that doesn't make any sense. I mean, it would be correct, but we could put in pi. We could put in 1 over square root of 2, or we could put in any number that you can think of. So this is a good way to think about functions, and this is how I think about functions, and this will be very helpful to you in thinking about functions when you're doing calculus.